Hey guys, we're going to use similarity again to solve some information. We want to know the length of line segment BD, which is just this section, not of this whole big triangle, but just this part of this triangle here. And we're going to use similarity to do it, but first we have to show that the two triangles are similar. And how can we do that? Well, I'm going to just show you really quickly. They both share angle A, right? Triangle ABC, the little triangle inside, and triangle ADE share that same side, which I'm going to just identify as a dot. But one angle is not enough to say that the two triangles are congruent. We need at least two. And it turns out, if you think about these lines being parallel here, this is going to look like something that we saw a long time ago with our parallel lines and our transversal, which runs right over here. And because I have these two parallel lines with this transversal, I can say that this side corresponds to this side. These are corresponding angles. And these two angles here also, by the way, would be corresponding. So you only need two corresponding angles in order to create the proof for an angle-angle proof. But this allows me to say that the two triangles are similar. So triangle A, B, C is similar to triangle ADE. And once I have the two triangles drawn, and I know which side matches which, in this case, they line up really easily compared to the last one, I have to start putting in information that I know. So I know that AB is 14. So that's pretty straightforward, though. And I know that AC is 12. So that's right there. And I know that BC is 9. So that whole little triangle is solved. It's pretty nice. The big triangle, however, is a bit more problematic. Now I do have this bottom length here, 31.5. So that's good. I don't know this, AE. I know that much of it is 12, but I don't know the rest, so I can't really use this side. And this is a bit weird over here on this side, AD. If you look at AD, we don't want to call AD X necessarily. We could call the whole thing X and then do some subtraction, or we can call it what it looks like, which is the whole side is this much plus this much. So X plus 14 is the measure of AD. And that looks weird because we're not used to having like a binomial or two terms of math represent a side length, but it's not too tough if you think about it, right? This whole thing, this much is 14, this much is X, put it together, 14 plus X. It's going to make our lives pretty easy. Now, because we know they're similar, we know that this 9 is going to be proportional to that 31.5 with the same scale factor as that 14 will be to that X plus 14. And so we can go ahead and solve the triangle now. I'm going to do it by setting up the ratio. So the measure of AB divided by the measure of AD will be equal to the measure of, let's say, BC divided by the measure of DE. So small side over big side, small side over big side. And I used the corresponding sides. So I can put my numbers in now. 14 over X plus 14. Keep those brackets there. It's very useful. You'll see why in a minute. And that's got to be equal to, so this one over this one is the same as this one, we said, BC over 31.5. 9, 31.5. They have to have the same scale factor. When I divide that side by that side, it has to come to the same as that side by that side. And what that allows me to do is cross multiply and solve for X. So I'm going to do this part first. That's pretty easy. That's going to be 14 times 31.5. Just show you the operation there. That's a multiplication symbol, just to be clear. And that's going to be equal to 9 times x plus 14. We like to put the number in front of the brackets, and remember there's a multiplication in there. So 14 times 31.5 is 441. And that's got to equal, now here's where you have to be careful. Everyone knows that 9 times x is 9x, but a lot of students now will mistakenly just put plus 14 here. And you have to remember that that 9 gets multiplied there, but it also gets multiplied there, right? We have to distribute that 9. So plus, clear that up, 9 times 14 is 126. And now we can solve for x pretty easily, right? We're going to subtract the 126 and then we're going to divide by the coefficient. So minus 126. So we're going to go 441 minus 126 is going to give me 315 is equal to 9x. And now divide both sides by 9. And when I do that, I get 35 is equal to x. Now I know that my x is equal to 35. Now, if they wanted to know the length of the entire line segment AD, I would have to add 35 plus 14. But they didn't ask for that. They just wanted to know BD, which I labeled as my x. So it's the same thing. First of all, you have to show that they're similar using similarity proof of angle-angle. And then set up your two triangles, draw them out. Make sure you label the sides in the proper order. This is an easy one to do that with. And then set up your ratio to find your scale factor or to use your scale factor. Cross multiply, don't forget to distribute your 9. Solve your x, answer the question. Good job.